Let's go over the process for using synthetic division as a replacement for long division. Now, just some quick things about synthetic division. You can only use the synthetic division process when your root, when you are dividing by a factor here of x to the first power minus a root. That root is going to be important to us in the process. And then also it's important to know that your polynomial needs to be written in decreasing powered order, and take note of any powers that are missing in your polynomial. So let's go over the steps. For step 1 in our synthetic division process, we need to make sure that we write the coefficients of the polynomial out in decreasing order of their powers. So I have 1 x to the 4th, 3x cubes. Notice that the x squared term here is missing, so I will write 0x squareds, negative 1x, and then 10 constants. So step 2 is to take the root here, so the 0 of x plus 2, and go ahead and put that up on a shelf. So what makes x plus 2 equal to 0 would be negative 2. It's always the opposite sign of what's in the actual factor. So we just put that up on the shelf, and now we have the setup for our synthetic division. So we can start the synthetic division process. Alright, so step 3 here is the actual synthetic division process. We are going to bring that 1 down. Then we take our shelf number and multiply the number by this. So negative 2 times 1 is negative 2. Alright, then we just add. 3 plus negative 2 is 1. Alright, step 4 is just to repeat that same process all the way until you get to the last term. So we have negative 2 times 1 is negative 2. There we go. 0 plus negative 2 is negative 2. And then negative 2 times negative 2 is 4. And write that underneath the next term. Negative 1 plus 4 is 3. Negative 2 times 3 is negative 6. 10 plus negative 6 is 4. That 4 is pretty important to us. That is the remainder of our polynomial. Alright, so now what we've done here is we've started out as x to the 4th and we've divided an x out. So if my polynomial started at x to the 4th, my new division here will be x to the 3rd. So step 5 is going to be to write out the new polynomial, which is our quotient, and the remainder. So I have here, if I started out as x to the 4th, my new equation will be x to the 3rd as its highest power. And the reason is because I did divide out an x by doing the synthetic division process. So what I have here is 1x cubed plus 1x squared minus 2x plus 3. And then writing the remainder is probably the most tricky part here. It will be plus a remainder of 4 divided by whatever the divisor was. So that's x plus 2. So my final answer is a polynomial x cubed plus x squared minus 2x plus 3. but then plus the remainder part. Knowing what that remainder is will be beneficial for a lot of different things dealing with polynomials. A lot of times we're going to want to get a remainder of 0. Let's take a look at one more problem. Alright, so I have the equation x to the 5th minus 6x squared plus x plus 1. Notice that I don't have an x to the 4th or an x cubed. So let's go ahead and write out the polynomial first. I have 1x to the 5th, 0x 4th, 0x cubed, negative 6x squared, 1x, and 1 divided by, and put the line there, and it's all divided by x minus 4. So the root that goes up on my shelf is 4. Alright, so those are the first two steps. Put the coefficients and then the number on the shelf. Then let's bring our 1 down. 4 times 1 is 4. 0 plus 4 is 4. 4 times 4 is 16. 0 plus 16 is 16. 4 times 16 is 64. 64 plus negative 6, so 64 minus 6 would be 58. 4 times 58 would be, let's see, 4 times 50 is 200. 4 times 8 is 32. So 232. So that's 233. And then 4 times 233 is 932. 1 plus 932 is 933. Well, that is a really big denominator, but that's okay. My highest power started out as x to the 5th. But because I divided out an x to the 5th, my new highest power here would be x to the 4th. So I have x to the 4th plus 4x to the 3rd plus 16x squared plus 58x plus 233 plus a remainder of 933 divided by x minus 4. And there is my new polynomial after I divide out x minus 4.